Now, we're going to go into our second section. This section is going to be really, really short, mainly because we're dealing with what we now call polyatomic ions. So we talked about monatomic ions. We talked about what happens when we have a regular metal, a transition metal, or a regular non-metal situation. Now we're actually going to look at what we talked about with a group of atoms that lose electrons or gain electrons in order to form or to be more stable. So our learning goal here, I'll be able to describe the difference between monatomic ions, mono meaning one, and polyatomic ions meaning many. So unlike monatomic ions, the polyatomic ion is composed of more than one atom. But like a monatomic ion, a polyatomic behaves as a unit and carries a charge. So for the examples that we're going to look at, we're going to note that even though it's made of more than one, and you're usually going to see a lot of oxygen thrown around in here, even though it's made of more than one atom, it's going to behave as though it's one cohesive unit, one piece that sticks together and has only one charge. So, looking at the structure of the sulfate ion, sulfate is what we're dealing with right here. Now, you notice that we have a sulfur here in the middle. This is our sulfur. And then attached to that, we have our oxygen. One oxygen, 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 oxygen. Now, these are all gonna be bonded together and sort of connected. They're sort of like glued together, I guess the best way to say. Now, with them glued together, they're glued together in such a way that they're still going to have a slight charge. And so maybe from this oxygen here, we're going to end up with a extra electron that's drawn in. And on this one, we're going to have another electron that's drawn in, giving it an overall 2 negative charge. Now, we're going to see several of these in the next slide and as we practice. So get used to seeing them and start to look at the names. Now, I want you to note something really quickly. ATE, ATE, ATE. Each of our polyatomics that are given here, except for ammonium, notice that they end in ATE. That's going to be very, very important. Now, here's some common polyatomics, and you're actually going to have a list of these in your slides, or not in your slides, in your packet. So you want to make sure that you go back and you review and understand how the formulas work, how the charges work, and also how to name them, because we're going to use that as we come into ionic compounds. Now, again, note that some of the names of the polyatomics end in ATE and ITE. The reason why we say some is because you get one every once in a while that is a little different, like ammonium in this case, or hydronium, which we'll talk about at another point. Now, this is where we're actually going to end this portion of it. And again, I told you this one's going to be very, very short. So take your time, review the information, make sure you're set to practice, and understand what we're going to do tomorrow in class. Have a good one, and I'll see you tomorrow.